Database is nothing but a collection of files, different files. For example, in our university database, there are different files such as instructor file, student file, advisor file, and you can say course file, department file, section file, time slot file, etc. So this is the collection. All these files together is database. So the database is stored as a collection of files. These files reside where these are stored, as the memory is very small. It is not possible to store the entire database in main memory, and that's why the database is normally stored on the disk, hard disk. And whenever the execution is required, that the data from the disk is transferred to the main memory. Actual execution is performed in the main memory, and after completion, again the data is transferred to the disk. So these files are resides permanently on the disk. Each file is a sequence of records. For example, each file is a sequence of records. So in this instructor file, there are 12 records you can see. Each file is a sequence of records. Now we are going to call it as a record. In relational database, what we call is as a tuple. Okay, so while in file organization or indexing concept, we consider or call it as a record. So there are 12 records in this file. A record is a sequence of fields. Instead of attributes, the word used here field. So each record is a sequence of fields. So this first record has 4 fields: ID, name, department name, and salary. Okay. So in this way, we call it as a group of files. Database is a group of files. Now, as we know that these files are stored permanently on the disk, the file size may be very big, hundreds of records, thousands of records. In our case, in our institute, only single institute, there are 2,500 to 300,000 students. If we consider a student table, only student table, then there are 2,500 to 3,000 records. So all these records are transferring from disk to main memory for execution. It is very difficult or very time consuming, costly thing. See once again, suppose there is a student file, okay, in our college. Now we are considering it is university. So in university there may be 10,000 students. In our college, if we consider, there are up to 3,000 students. So as there are 3,000 students, 3,000 records are there. 3,000 records are there. Suppose we want the information about a particular student. We want the information of a student with name is equal to with name is equal to. How can select student where name is equal to? So this is executed memory, but records are stored on the disk. Where the records are stored, this entire student file is stored on the disk. Now, during the execution, this student file is transferred from disk to main memory, and where the execution is performed and the student record with name is equal to xyz is retrieved. Now transferring this entire 3,000 records, see, transferring the entire 3,000 records, it is very time consuming and costly. Transferring all these 3,000 records from this disk to main memory is very costly and time consuming. Okay. Now, how to avoid this? How to minimize this space, or how to minimize the time required? How to minimize the cost of data transfer? For that, the records in this file, 3,000, suppose there are records in the file, these all records are logically partitioned into fixed length storage unit called blocks. These records are partitioned into fixed length storage unit called the blocks, which are units of both storage allocation and data transfer. Means, for example, suppose we consider that 3,000 records are there in the student file, and one block there are 10 records. We consider that in one block there are 10 records. Okay, so While retrieving the record with the name XYZ, only the block where that record is kept is transferred from disk to main memory. Remaining blocks are not transferred. Only one block with that 10 records are transferred from disk to main memory. Execution is performed and again the block is returned to the disk. Means only 10 records are transferred from disk to main memory. If the block concept is not used, what we require? We need to transfer the 3000 records from this to main memory. And it is very costly and time consuming. Have you understood what is the use of blocks? The records are partitioned, logically partitioned into fixed length storage unit blocks. And while execution, these blocks, only one block where the actual record is stored is transferred from this to main memory and their execution is performed and again returned back to the disk. How that record is found, how that block is found, again is the next concept we are going to study. Everyone clear what is the concept of block? So in this example, you can see here, these 12 records, 4 records are in one block. 4 records are in one block. So you can see here, block number 1, there are 4 records. Block number 2, there are 4 records. And in block number 3, there are 4 records. So if we write the query, select star from instructor where ID is equal to, suppose I write the query, select star, sorry, from instructor, okay, where I is equal to 45565. Suppose this query I execute in main memory. What happens when I execute this query? It finds out the block where the record with ID 4565 is stored. So where is that? It is here. Okay. So where it is? It is in block number 2. Where the record is stored, it is in block number 2. So when this instruction is executed, it first find out the block where the record is stored. This block number 2 is transferred from this to main memory. Where it is transferred? It is transferred from this to main memory. Their execution is completed. Once the execution is completed, this block is returned back to the disk. And what strategies are used to return back to the disk? All these things we are going to study in buffer management. Everyone clear the concept of block? So most database use size of block 4 to 8 kilobytes by default. So in 4 kilobytes, suppose there are 10 blocks or 4 records can be stored. So in this example, if we consider 4 records in one block number 1, 4 records in block number 2, and 4 records in block number 3. Is it clear? It is very important concept because the remaining things are depend on this concept. The transfer of blocks from disk to main memory, again return back to the disk. Again, we are going to see the same concept again and again. So understanding this one is very important. What is block and what is the purpose of block? Why blocks are used or the concept of block is used. So always remember each file is logically partitioned into fixed length storage unit called the block. Is it clear to everyone so that I can move to the next part? Yes or no? Okay. So this is about the blocks and files. So how these records are stored in the file? This is instructor file, student file may be there, course file may be there, department in this way. So how these records are stored in the file? There are two ways to store the records in the file. Two approaches, fixed length record and variable length record. Both we are going to study in detail. Fixed length record, assume record size is fixed. Consider that the record size is fixed. Every record is of some fixed size. For example, we consider every record means the first this record of instructor, every record is of 40 bytes. Okay. So every record is ID, name, department name and salary. All together, one record required 40 bytes. Assume that record size is fixed. For that, we need to use the fixed length data. Each file has a record of one particular type only. Means in a file we store only instructor related records. Okay, no mixing of instructor, student, course, department together. So each file has a record of only particular type, one type only. And different files are used for different relation. Means for instructor relation we use instructor file. For student relation, we use student file. For course relation, we use course file. For department relation, we use department file. So clear fixed length record. Assume that every record is of fixed size. For example, 40 bytes. Every record is of 40 bytes. Each file has a record of one particular type only. Means if a file contains instructor record, all are instructor records only. And for every relation, we use different file. Now variable length record. So storage of multiple record types in a file. Storage of multiple record types in a file means we use instructor along with the courses that taught by the instructor together in one file. Instructor and course together. Or we use student and the course taken by the student together in one file. So storage of multiple record types in a file. Record types that allow a variable length for one or more field means if we use name as varchar. So variable length, if the record type is a variable length, then every record requires a different size. So it becomes the variable length. And record types that allow repeating fields such as arrays or multisets. Repeating field means phone number. So two phone numbers we are stored in an array. So three phone numbers is an array. So that concept is used in object-oriented database. In the advanced database we are going to study. So these are two approaches, fixed length record and variable length record. These are used to store the records in file. So first we are start with the fixed length records. Now fixed length records, as I have told that every record is of same size, fixed size. Then every file store the same type of records. Okay, type of record of same size. Let us consider, we start with the example of instructor. For university database, type instructor record ID character 5 means this ID of the instructor requires 5 characters. Name character 20, department name character 20 and salary numeric 8,2. Now here we consider that the one character requires 1 byte. It's for consideration, one character required 1 byte. Normally it is there. One character required 1 byte. So how many bytes are required for ID? 5 bytes are required for ID to store the ID. We consider one character for 1 byte. So to store the name of size 20 character, we require 20 bytes. Similarly, department 20 characters, so 20 bytes. And numeric 8,2 we consider it requires 8 bytes. Okay. So total, how many bytes are required to store one record? See, ID 5 bytes, name 20 bytes, department name 20 bytes and salary 8 bytes. So how many are required? How many bytes total required to store one record? Calculate it. How many total bytes? Calculate fast. For one record, 53, correct? So to store the first record, it requires 53 bytes. To store the second record, it requires 53 bytes. So the size of record is fixed. Have you understood the first one? And in this file, we store only the instructor record. And that's why it is fixed length record type. Now, as 53 records are required to store, 53 bytes are required to store one record. So, simple concept is used that, simple approach is that first 53 bytes are used for first record, next 53 bytes are used for second record, and so on. Is it clear to everyone? A simple approach is that first 53 bytes are, suppose a file, the block is of size 530. So first 53 records are used for first record, next 53 bytes for second record, next 53 bytes for third record, next 53 bytes for fourth, fifth. So in this block of size 530, we can store 10 records. Is it clear? First record is of 53. Next bytes are 53 bytes are used for second record. Next 53 bytes for third record and on so on. So that is a simple concept used to store the record in the file of type fixed length record. Now, what problem occur while we insert the record and when we delete the record, that we are going to see, or we are going to see how to insert the record, new record, and how to delete a record from such kind of file. So first we are going to see the insertion. Okay. So there are two problems with this insertion. You have to how to store the record. Simple. Suppose I want to store the next record. To store the next record, it is stored as record number 12. Simply, the insertion is simple. For example, 9899 with name John. Okay, with department physics, with salary 70,000. So next 53 bytes after this, whatever are used for the next record. Similarly, the record number 13 and so on. Is it clear to everyone the insertion? Now see what problem occurs in this case with this simple approach. So here we consider that the block size, there is a particular block size. Okay. Here we consider that the block size is of, see, listen it carefully, the block size is of 530. Then how many records we can store? 10 records we can store. Okay, one block, so one record of 53 bytes. So total 10 records we can store in this one block. But if block size is of size 550, okay, block size is of 550 bytes. So how many records can we store in this? Anyone? Suppose the block size is of 550. If it is a 530, entirely 10 records we can store in the block. But if block size is 550 bytes, then how many records we can store? Each record is of 53 bytes. How many total records we can store here? Anyone? Hmm? Ten records, correct? So in total, we can store the 10 records, entire 10 records. Entire 10 records we can store in this 150. But what happens here? How many bytes are remaining? 20 bytes are remaining. 20 bytes are remaining. Now, as per the simple approach, after these 10 records, next record 53 bytes, okay, Among that, 20 bytes are stored in this block number 1. 20 bytes are stored in the block number 1. And the remaining, how many remaining? 33 bytes. The remaining 33 bytes are stored in block number 2. In block number 2. Understood? See, if the block size is 550 bytes block size, then in that case, 10 full records we can store, or entirely we can store 10 records. But the 11th record, only 20 bytes we can store in block number 1, and remaining 33 bytes we need to store in block number 2. So, what problem occur with this? When we want this record, that 11th record, if we want to retrieve the 11th record, we need to access both the blocks. We need to access both the blocks. That is block number 1 and block number 2. And this is again the costly and time consuming. We require to access more blocks. See, transferring the data from this to main memory requires some time. So, accessing these both the blocks is required in that case to retrieve the 11th record. Everyone clear with this concept? This is one of the problem with the insertion. That problem may occur with the insertion. That if the block are not entirely, if the particular record is not entirely stored in first block, we need to store the remaining bytes in the second block. And if we want to retrieve the 11th record, that 11th record, who 20 bytes are stored in block number 1 and 33 bytes are stored in block number 2, we require to access both the blocks. I need to transfer both the blocks from disk to main memory, which is costly. This transfer is costly, always costly, and that's why we need to minimize the disk access. For that, the simple concept is used that if some bytes are remaining, if that record is not entirely stored in the particular block, 20 bytes are remaining here, and we are trying to store the 11th block, which requires total 53 blocks, 53 bytes. So in that case, the remaining 20 bytes, these are kept blank, or these are kept unused. These remaining 20 bytes are kept unused. That is one of the solution to minimize the number of disk transfer. Remaining 20 bytes are unused. Is it clear to everyone? Insertion, fixed length records. Insertion is right with the fixed length record. Simply, a simple approach that we use first 53 bytes for the first record, next 53 bytes for the next record, and in this way. So, after record 11, if we want to store the 12th record, we store it in the next 53 bytes. But the block size is important. If there are 530 bytes block size, then 10 records we can entirely store in it. But if the block size is 550 bytes, first 10 records entirely we can store. But the 11th record, 20 bytes we store in block number 1, while the remaining 33 bytes is stored in block number 2. And if we want to retrieve the 11th record, then we need to access both block number 1 and 2. Need to transfer both block number 1 and 2 from this to main memory. It is time consuming and costly. So the simple solution is that the remaining 20 bytes are kept unused. The next record is stored in the block number 2 to avoid this accessing multiple blocks. Is it clear to everyone? So if we want to delete a record in this file, there are three approaches. The first approach is that delete the record simply, remaining records up. Second approach is that move the last record at the place of deleted record. And third approach is to use the pointer method or the free list method. So all these three we are going to see with example. So there are three options. Move record whatever the after deleted record up, and move the record 9th record, last record at that place of the deleted record, or use the free list method. So first that, the Suppose we want to delete the record number 3 from this file, or this record is deleted. I use the query that delete from instructor, where id is equal to 2222. Suppose I execute this query. So when I execute this query, what happens? The record number 3 is deleted from this instructor file. Now when the record is deleted, what about the space, 53 bytes which are occupied by this record? The first approach is that move the remaining records from 4 to 11 up. Okay, that is shown here in this next PPT. So after record number 2, the next record is record number 4. So remaining 4 to 11 records are moved up one by one. But deleting in this way and moving the remaining records, it is costly. As I told that there are 3000 records in a file, and if we delete the record number 2, how many records we need to move? 2998 records. So it is very costly and time consuming to move such kind of records up. So this method is normally not used. So such an approach requires moving a large number of records. What is the next one? The last record move to the place of the deleted record. Means here at the place of record number 3, we move the last record, that is 11th record. But what problem occur with this? That even the record, if it is in the second block, as we see already the example, first 10 records in the first block, from 11 to 20 in the second block, 21 to 30 in the third block. So moving this 11th record in this place, what requires? We require to access that block or transfer that block from disk to main memory, and then it is possible to move the record. So again, it is undesirable to move the record to occupy the space freed by deleted. In doing such require additional block access. If the last record is in the another block, we need to transfer this block from disk to main memory. Again, this moving is require another disk access or block access. So that is also not desirable method to use. The next method is that the free list or pointer list. Have you understood the first two methods? See, this question normally asks for 6 to 8 marks. Explain or illustrate the fixed length record method with insertion and deletion. Okay? And the same concept. See, this question normally asks illustrate the fixed length record method with insertion and deletion. The same method, insertion and deletion, is used in sequential file organization, because sequential file organization is same as fixed length record. So the again same concept is there, so I am not going to repeat it again. I am going to ask you what method is used. Same deletion methods are used there in sequential file organization. In that also such kind of question is normally asked. Explain sequential file organization method with insertion and deletion. So remember the concept of insertion and deletion. So the first thing is that if we delete a record number 3, remaining records we move up. But it is time consuming to move the remaining records if there are so many records are there after the deleted record. Another method is that move the last record at the place of deleted record, but if last record, nth record, is in another block, it requires additional block access, and that is also not desirable. So the third method that used is use the free list. So what is used in the free list? First record is kept blank as a header. First record is kept blank as a header. So first 53 bytes are used as a header, which contains the address of first deleted record. Which contains the address of first deleted record. You can see here. You can see here. This contains the address of first deleted record. What is the address of first deleted record? Consider it as a 1. So, record number 1 is deleted. This first deleted record contains the address of the next deleted record. It contains the address of the next deleted record. Next deleted record is record number 4. This record contains the address of the next deleted record, means it is record number 6. So it acts as a pointer chain which point to the deleted record. It shows that this is the deleted record, this is the deleted record, this is the deleted record. This is known as pre-list method. Now suppose I want to insert the next record. Okay, I want to insert a next record. So I first go here, check the header. Is there any deleted record where the space is available? So at this place I am going to insert new record, suppose 98999 with name with department physics and something 80,000. Okay, now in that case, once I insert a record at the place of deleted record, change the pointer chain method. Here it points to the this one. Now this is the next deleted record. So whenever we insert a record at the place of deleted record, this pre-list or the pointer is need to be changed, indicating that the first deleted record is record number 4. After that, next is record number 6. Everyone clear with this method? It's a simple method that the first 53 or the first record is kept as a blank header which contains the address of the first deleted record. First deleted record contains the address of the next deleted record. This record contains the address of the next deleted record. So whenever we want to insert a new record, we follow this pointer. It points to the first record, deleted record, where the space is free. It is a fixed length record, all are 53 bytes, we can store it easily. Insert here, suppose another, now the pointer points here, so it is 11111 something department in this way. Now points to the next deleted record. So that is a simple way to deal, and this is the way used everywhere. Instead of using the first two methods, the third method is used because it not requires so many block access and it is required minimum time for insertion and deletion. In a file, we use the variable length records. Records that allow variable length means varchar we use, then it has a variable length record, or record types that allow repetitive such as arrays or multisets. That part is in object-oriented database. Now, see here, there are two ways to store the variable length records. As in this, there are three ways to store the records or delete the records in fixed length records. In the variable length record, there are two ways to store the records. The first that we are going to see here, the example is given here. I will explain it in detail. The representation of record with variable length attribute typically has two parts. So this representation is divided into two parts. An initial part with fixed length attributes. Okay. First we store the fixed length attributes. For example, suppose ID, name, department name and salary. Four attributes are there. ID, name, department name all are varchar and salary is of numeric type or integer type. So that salary is a fixed length attribute and remaining three are variable length attributes. So initially we store the salary. So it is, you can store, see here, first salary is stored 65,000 and then the remaining three records are stored, that is ID, name and department name. Okay. So first initial part fixed length record is stored and then variable length records are stored. Fixed length attributes such as numeric values, dates, or fixed length character strings are allotted as many bytes as required. So integer we require 8 bytes, numeric 8,2 if we consider require 8 bytes. So 8 bytes are allocated for salary here, that is from 12 to 20. Okay. Variable length attributes such as varchar types are represented by offset comma length first. What is this offset comma length? Offset denotes the position where the actual record is stored. Offset indicates the position where the actual record is stored, and length is the length in bytes for that record. So you can see here 21,5. This is the offset for ID. What is 21? It is the offset indicating where the record is stored. It is stored at position 21. At 21 byte location it is stored. So offset represents the location, and 5, how many bytes it required? 1 character 1 byte means 5 bytes it required. It is its length. Now at 26 location name is stored. So the first offset is 26. How many characters it is? It is of 10 bytes. 10 characters 10 bytes are required, so 26, 10. Now the department name is start at location 36. So 36, it's a 10. This 4 dot is also considered, space is also considered. So total 10 bytes, 10 characters, so 10 bytes are required. So 36, 10. So these first are used. Variable length attributes are represented by a pair offset, length. Offset represents the location and it is the size required to store that particular attribute. Now see how many bytes are required this offset. We consider 2 bytes for offset, 2 bytes for length. So total 4 bytes are required to store this pair. Total 4 bytes are required to store this pair. So these 4 bytes for ID, these 4 to 8, these bytes are for name, and these 4 bytes are for department name. Is it clear up to this? After this, how many number of attributes are there variable length? 3 attributes are there of variable length. That is ID, name and department name. So 3 pairs are there. 3 pairs are there. 1 pair requires 4 bytes. Total first 0 to 11 bytes are required for storing these 3 pairs. If there are 4 attributes of variable length, another next 4 bytes are required. That is about this pair. Now after that, the next is stored as fixed length characters or fixed length attribute. So fixed length attribute is salary only. So here we store the salary for 8 bytes 12 to 19. Now this 20th byte, okay, for which purpose it is used? It is known as a null bitmap. It is known as a null bitmap. So what is this null bitmap? If it is 0, 0, 0, all 0 means there is no null value. There is no null value. If salary is null, for example, is there a salary in that record is null, then this null bitmap becomes 0, 0, 1. If department name is null, third attribute is null, then it is 0, 0, 1, 0. If name is null, then it is 0, 1, 0, 0. So that null bitmap is used, and after that variable length attributes are stored. 5 bytes store ID, next 10 bytes store name, next 10 bytes required for the department name. See once again, in this variable length record representation, if we consider it as a single record, this from 0, how many total bytes it required? 45 bytes it required. Okay. In that, first fixed length records or fixed length attributes are stored and variable length attributes are stored. For every variable length attributes, we store a pair offset and length. Offset represents from where that variable length attribute start, and this length represents the number of bytes it requires. So here it indicates that the ID start at location 21 and the size 5 bytes. Srinivasan name, it start at location 26, required 10 bytes. Computer science department at location 36 with required 10 bytes. And after that, fixed length attribute, that is salary, which required the 8 bytes. That is the numeric 8, 2. Along with that, here null bitmap is used to indicate that which attribute is null in that record. So in this record, there is no null attribute, so all are 0. If salary is null, it becomes 0001. If name is null, it becomes 0100. If department name is null, it becomes 0010. That is slotted page structure. That is the second method to store the variable length record. So first we see here the diagram. Simple diagram is shown here. First we study this diagram. What is it? So in slotted page structure, the initial part is used as a header. Suppose this is the entire block. Normally the block size is 4 to 8 kilobytes according to the database. So we consider that this is the entire block in which we are going to store the record. Now you know the block is nothing but the unit of storage allocation and also the data transfer. So it is normally stored on the disk. Whenever we execute any instruction and if in that case the record stored in that block is required, then that block is transferred from disk to main memory. So that is the block. So if we consider this is the entire block in which we are going to store the records, the initial part is used as a header. What it includes? It includes the entries. Okay, what it includes? The slotted page header contains the number of record entries. Means in this case, how many records are there? If for example, there are 4 records. Okay, there are 4 records. So the entries here you can say 4 records. In this there are 4 records. Now this is indicate the location of or end of free space. Free space means the space which is available to insert the new record. So along with the entries, number of records, along with it contains the end of free space or the location which indicate or locate the end of free space where we can insert the new record. Then it contains an array. What is that array? Which consists of the entries, location and size of each block. Location and size of each block. For example, this one is the location of this block, block number 1. So indicate that block number 1 is record is stored here. Okay, record number 1 location. And the size of this record, suppose this record is of size 10 bytes. This record is size 10 bytes. So size of each record. Now the location of second record, suppose this is the second record, it is its location of second record, and the size of, suppose its size is of 30 bytes. Okay, so here it's over 30. In the same way, array is used whose entries contain the location and size of each record. That is about the header. See again, this block contains first initially header. The header contains the entries, means the number of records in each block. Now in this block, suppose there are 4 records, then it stores the entries, that is 4, indicating that there are 4 records. Also, it gives the address of the end of free space where we can insert the new record. Then along with it has an array whose entries contains the location and size of each record. Now see how we can insert the record and delete the record from this slotted page structure. Suppose I want to insert a new record. Now this new record is always inserted at the end of free space. Where it is inserted? It is always inserted at the end of free space. So here it is inserted. Suppose this is record number 1. This is, sorry. Suppose this is record number 1. This is record number 2. This is record number 3. This is record number 4. Now I want to insert a new record, that is record number 5. So where it is inserted? It is always inserted at the end of free space. So it is inserted at the end of free space, that is record number 5. Now along with that, what we need to change? We need to change the header. In the header, now how many entries are there? How many records are there? 5 records are there. So entries now 5. Now the location indicating the end of free space. Where it is now? It is now here, indicating the end of free space. Now These are changed. Along with what we need to do, we need to add a new entry in the array. What it includes? The location of the new record along with the size of the new record. Suppose if the size is of 5 bytes, so size of new record, or if it is 50 bytes, size of the new record. So in this way, the record is inserted at the end of free space. So free space is always between the last entry in the array and the first record. The last entry in the array and this record, in between there is always free space. That is about the insertion. Is it clear to everyone? Another example I will give you. Suppose I want to insert another record in this. Where I need to insert it at the end of free space. Now it is record number 6. Now it is record number 6. Along with what we need to do, we need to add a new entry in the array. And indicating here the location pointing to the end of this location and the size of that particular record. If it is of 20 bytes, the size of 20 bytes, and change the free space. Where now free space goes? The free space now goes here, indicating it is the end of free space. Now suppose if we want to delete a record from this sorted space structure, what is used? If I want to delete this record number 3, so in that case, simply all the records, all the records after it towards the free space are moved towards the deleted record. Means this record is moved at this place. This record is moved at this place. Okay, so it is moved here. What we need to change along with that? Either we need to delete the entry where it is. This record we have deleted, so its entry is here. So either we need to delete the entry in the array, but most of the database it is not allowed to delete the entry in the array. Instead of that, here the null value is stored, indicating that the record is deleted. And what we need to change here? The entries we need to change here. Now from 4, now there are only 3 records, and the free space it is from here goes to here now. So in this way the record is deleted. See, once again I am telling you, suppose I want to delete the record number 3. Suppose I want to delete the record number 3. So this record we first delete. After deleting this record is moved. Whatever the records after it moved to the space of deleted record. Then the array entry which indicating this or locating this particular record is either deleted or make it null. Most of the database not allowed to delete, make it null. Entry is decreased by 1 and the free space now it is pointing to the new location. Means whenever we insert a record or whenever we delete a record, we need to keep a free space which is always between the last entry in the record or the last record and last entry in the header. Everyone clear with the slotted space structure? That is the simple. Now what is here that we delete the record and move the remaining record. If we delete this record, then we need to move the remaining 2 records at this place. So as I told that the movement is actually costly, but it is within the block and the block size is limited up to 4 kilobytes, and that's why this movement is not costly. In a block, if there are only 10 records, the movement is in between the block only. So if the block size is only 10 records and if we deleted the third record, we need to move only the 7 records, remaining 7 records. So the block size is limited and that's why this movement is